Nerding and Hoarding. Quick and dirty DIY electronics. And welcome back. Today we're gonna keep on going with this quick and dirty Vactrol Vocoder. We are going to take the schematic we finished in the last video and turn it into a PCB, which is a printed circuit board. Anyway, what we have here is all of the components in just a total mess here. And you see these little blue lines, these lines here, they show how everything should be connected. So the only thing we have to do is take every component and put it inside of this. So this is the actual board. So we could maybe start by writing a little text here, but wait a minute, that is the red layer. So we need to talk a little bit about the layers here. There are several layers. If we could just get this thing to stop popping up and down and sort of just be up all the time. Okay, so the red layer and the blue layer are used for the copper connection leads on the back side and on the front side. So red front side, blue back side. So we don't want any text in there because that's just going to make it give us less space to have components. But what we could use is this. It is a printed layer. Silk screen print on the front side is yellow and on the back side is green and mirrored like this. So what we do then is we just write something here. Vocoder. Yes. Beautiful. Oh, this is irritating me so fucking much. I don't know what it is with me today, but anyway. Don't fucking... Alright. So what we need to do is make some kind of plan. What is actually the... Do we have anything that matters in how we design this thing? As you see, usually I do like this. I always take this one and put it sort of here. So this is where the power comes in. So it could be good to have it here. Sort of like this. Maybe we also want to... okay, so we can also maybe look here and look at if we have some way we want this to be structured maybe. We could gain some... if we put it sort of close to the layout here, not exactly, of course, but somehow in the not very much different. So if we start with the lowest numbers of capacitors and resistors, we might actually be able to get more things into less space. So if we go back here and okay, I'm just getting overwhelmed by seeing all of those lines, rat nest lines. So what I'm actually going to start to do is to take all resistors and put the code inside just like that. Because if I don't do that and I put a lot of resistors next to each other like this, which I usually do, then you see it looks like this is 11, but it is actually 10. So therefore, if we do it like this from the beginning, we don't mess anything up. But there's another thing I wanted to say. There's something called snap. I think it's called snap anyway. Snap. There is a grid. And that's these things right here, the white things, and we can set them in different sizes. So why don't we set them in 1 millimeter, for example? Is because I'm European, so I'm using this kind of measurements. So now I put also a snap. So you see it's sort of snapping a little bit. So it moves and then snap, snap, snap. And that makes it easier to get everything sort of similar. So I will just keep on doing this with every resistor first. Just put it inside. And because there are very, very many components here, this is going to take a while. So I will just pause the video. Yes, another thing that I just realized is that we are now only having the codes. So there's R47, R4, but we don't have the values. So if we would want the values, which I do want now, then Let's see, how do we do that? Well, I think we do have to do like this. Select every component and then take that we want. Display name yes. Let's see what happened. Yes, we now also get a value here, which is good because it will help us when we are trying to build the thing. It's just you need some method of putting it in proximity to the thing that it is representing. So here, if I was to put it like this, it would be very, very confusing. So that's not so good. You see, it looks like R2310, okay. But if we would do the other way around, that would be better. But it's still not really so good, I would say. So maybe more like this. Or we could do maybe like this. Could also be another possibility. Yeah, I think I will go with this method. And again, maybe you don't want to see this on a long video. So I will pause again. As you see, this can be a rather long process. Ray, welcome back. Now I think I have put every resistor number inside of that symbol. So what do we do next? Well, I'm not sure. I'm not an expert on these kind of things. But maybe we should just start here and follow this line and see what components are in this line. So it's sort of maybe we could even go with these 3 lines here. So we get sort of between R2 and R12. And then it just goes on here all the way to R23, 24, and here 27. So between 2 and 29. Yes, so just group. Let's group all the components between, no, all the resistors between 2 and 29. And now we could move them close together like this. You see, like that. Beautiful. And we can also try to keep them in number or in number ordering. I don't know what it's called in English, but this doesn't matter, because it's just yes, man. Yes, where it's at. And you know where I'm at. Yes. So just put them in like descending, ascending, whatever it's called. Just as a beginning, This is just the beginning of something that we will keep on working with. So I will just pause you and you. Okay, now I have put everyone between all resistors from 2 down to 29 right there in a nice line like that. So now it's time for the capacitors. So capacitors go from 1 all the way till 20 and 21. So from 1 up to 21. So we need to make up some kind of way how we can make it look a little better. We can't maybe put all the text inside of the actual component, but we might make up some idea, some system method of doing it to make it look kind of easy to understand and not take too much space. One idea could be to put code to one side and value on the other side, like that. But there are probably better methods. I think I will use this method right now. And let's see how it will go. Yeah, I lost number 3. So now we have to find number 3. Where is number 3? Maybe it doesn't exist. Sometimes it just skips over a number, and that's totally okay, you know. You don't have to feel bad about that. That's totally fine, you know. You're still a very good electric engineer-ish hobbyist. I was thinking a little bit about a method that could be useful if you want to make it easy to assemble. Then you would put every value of the same value next to each other. When you have sort of very mixed values, it's easier to make mistakes. But you know, it's just you know you have to weigh one thing against the other because it's just you know one thing or the other thing. Hello. Yes, I have been trying to make a little layout here, and so the voice part seems to be getting along quite well. So this is the synth part, and here we have resistors 39, 38, 37, 35, 28 up to 54. So it's probably all of the resisting ones. Resisting? No, the existing. Now, all the ones that are left should probably be put on the other side. So that's not rocket science for you. It's very boring monotone work like this right here. Just do like this, you know, one after the other. Put them nice and neat together. But probably, you know, it could be maybe better to put them like this in order for us to be able to get more easier to solder, and it's easier to make routing in between here because there's more space. But we will worry about that a little bit later. Now we're just mainly worry about getting everything to fit on the board. But we remember the board has two sides, so we will probably not be in a worry. But you know, there's also everything goes through, you know, right through it. So there's holes, you know, the through hole components. So we still have to get stuff to fit anyway. But you know, I don't care. I don't care. Hello, hello. So I have been putting stuff in here, and it's looking very crowded now. But you know, I'm having a problem because I'm using these sort of super double footprints that I made, but they take too much space, and I need only a standard trim pot. So I have to fix that in somehow. So that will be a little bit of a search. Hello, I'm going to show you how to manually change a footprint, sort of. So I take a component here that I have the right footprint. I put it in a new schematic and I save this, file save, and then I take design, convert to PCB. And then it makes a PCB out of this. Then I just copy this, Control C, and I go to my actual, where I'm working on. So remember to select everything, Control C, and then we go to here and we paste it as many times as we need it, which is 7, I think, for this, like that. And so now we can rotate it, and then we look at here. So we have to look at the net here. So we click on a particular pin, and we take properties, and we look at the net. So the net of the square connector is V2. So we copy that. Then we do the same here, properties, net, and we change it to V2. Update. Only this pad. And then we do the same for the lowest properties, the net is ground, Control C, and properties, net ground, yes, only for this pad. And then we do it for the third leg, properties, round, Control C, console, click, change the net, bam, only this pad. And then we can actually check this by turning on the red lights again. And if it's correct, this one should be connected to that one, which it is. This one is connected to this one, and this one is connected to that one. So then this one is ready, and we can also change the name. So we have to select to show the name, yes. And then we change the, let's see here, we click this. Let's just do it the proper way and look at, so we have to find the name of this component, properties. Yes, here, the name is question mark. So copy that, and then we take properties for this component, and the name we change to question mark, and then we take the properties, and it's easy to get things wrong here. Properties. Yes, it is trim1. We know it's trim1 because it says here. So we just copy that and we take it, paste it there. And then we can rotate it and says that it has, we don't really know the value of it because we will test that. So like this. Now this is ready. So now we could delete this one and use this one instead because they have exactly the same nets here. We can move it sort of up here if we want to get a better look. Yes, this is connected to that, that is connected to that. So then we just have to do this for our other. We could even delete these now because now we can use this, copy this, Control C and Control V. And yeah, we could actually line them up a bit better just for us to be able to see a little bit better, like this. So in the order of their numbers, so to speak. This number 8 here, it's doing something else. I forgot exactly what it is, but let's put it here. And we take this, copy it and paste it all along here underneath the one they are going to become. So now we can see this is already done here. These are ground, these are ground. So now we only have to change this one, the square shape, and that is called V4. So just change it here, V4 update, only for this pad. And then we go to the next one. Okay, we can actually see here 6. So then we change this one to no. Now we have two things selected: properties V6 update, and then this one is V8. So make sure you only select one and then change that as well to V8 update only for this pad, and then to the next one. And what is this? It's V10. So properties V10 update only this pad, and then finally, I hope finally, so this is V12. So change this one, and then the next one, which is called 14. Sorry. Okay, what am I doing? Yes, this one, properties V14 update, and only this pad. And there we go. We are actually, so now we can save, and now we can actually delete these right here. So look, when I delete this, what happens to the red lines? Well, it just moves over to here, which is exactly what we want. And now we're just gonna find a good place to place these, because we are both having a little problem of where to put it. It's a bit crowded on this little schematic pomatic thing. Yes, so we just sort of move things around a little bit. I mean, it's not rocket science, this, it's just sort of playing a puzzle or cleaning your apartment or whatever, refurnishing your apartment. Just move around the furniture, you know, until everything fits nice and neat. So one part of me says, please make it so that all of them are close to each other. So maybe I should follow that guide. Because they share a lot of, all of them share the same ground connector. So if we take them all, rotate them and put them on top of each other, Maybe like this. Oh, this is so boring. Why did I get this hobby? Tell me, why? Why didn't I get another hobby? Like knitting or something. It's much more fun. This is so boring. Oh my god, I'm going to throw up. Well, it's probably self-punishment or something, because I think that I am worth punishment. I mean, I deserve to be punished because I am so evil, yes. Oh my god, what evil I am. Alright, so we got 4, which means we only have some to go. 3 more, and yes, now I realized, yes, I am having a cold, that's why, yes. It makes me get very short-tempered. So that's why I think it's just a boring hobby. Usually I like this hobby, that's why I have it, you know. I chose it by my own choosing. Well, not really, you were brainwashed, yes, of course. I was brainwashed by an evil conspiracy, yes. Okay. So that is going to look really good, actually. This is making me so proud of myself. Definitely. And this one goes here, and this one goes here. And then I don't know where the next one will go. Is this good? Yes, it's very good. You're such a talented and young artist. You will definitely win the Mayflower Crown Victory Medal of Honor in the next election of who is the best artist in the world. Well, thank you. That really heated up my brain in this time of need that I have, you know. All right, so now we save and we just do a sort of a test routing now. It is not defined. The routing is just to see how possible it is to route it. And if we look at this, how fast is it going up to 100? If it's just going really fast, then we know it's really simple. But if it's sort of getting stuck here at 95, 96, and then jumps back down and from going back and forth, back and forth, back and forth, then we know we have to make some adjustments. And it seems to go quite all right. But you see, when it starts to tick downwards, okay, and we didn't get any fail, so that's really good. So it actually managed to do it, you know, which is really good. Really, really good. All right. So I will do a little bit more work on this later, but now I am really not in the mood to do that. So what we do is just show you how to actually go on from here. So how do we go on from here? Yes, what do? We save. Bam. And then we have to write something here so we remember what it is. We need a code number. So, no, what happened right there? Undo, directly undo. Okay, Control C, Control V. So this is the number 666. Yes, and who is making it? Well, of course, it is the Hoarding. You know, Control C, Control V. Yes, bam, and we write that. Nerding, and but we have to write it in sort of parts here because it's so large, so we have to shrink it down. Nerding, and then we write and then we write hoarding there. So this will look really designed because I'm such a good artist, you know. Did I mention I won the golden medal in the World Trade's honor medal? Do you know my fame? Oh, this is really ugly design as well, but it doesn't matter because, you know, because what? I don't know. Do you know? No, you don't know because how could you ever know? And this is just because I am such a cool metal guy, I have to have this number. Anyway, vocoder, yes, and we also need to write this quick and dirty because that is exactly what it is. quick and dirty, like that, quick and dirty, because that is actually its actual name, you know. So we can actually do this old method. This is a real old method that they used to use in the older days, you know. It looks actually quite good, I would say. And we have to just shrink down the text a little bit more, so it's not going to be possible to read it, but that doesn't matter because, you know, we are cool. And all right, so then we take save, and yes, we are ready. So then we export a boom, which is one thing that we really need to have, and we export it. I don't remember exactly what kind of file it's going to be, but put it in the correct folder. So we have our project folder right here. Yes, save. All right, so, and then we take export Gerber file. Yes, check DRC. I don't remember where that is, but, and then we have our little file here. I can click Gerber view here. I don't know what that will do, but it doesn't matter. It doesn't work. Anyway, generate the Gerber file, and we save that there. It's a zip folder. And then we can go to online manufacturer. So and you know, there are a lot of manufacturers out there, so make sure you do some research before you choose one. And then we add the Gerber file here. So then you must remember where you put it, or the Gerber folder, which it actually is. And then yes, it's uploading it, and we can click on Gerber viewer here, and you have to sign in here. Keep going, keep going, keep going. I'm not exactly sure if this is working, but you know, hopefully it's Gerber viewer. Hello, hello. Did you upload that file, or what's the problem here? There seems to be some kind of problem. All right, so I have to upload it again. Where is it? It is there. Yes. Let's see what it is, how it will work, and all of that. All right, so then we can look at it if we want to look at it, because we can see how it's going to look when they send it to us. We can look at it in 3D like this. Oh, it's so beautiful. How does it look on the backside? Ooh, such a beautiful backside. And then we remember, like, oh yeah, you know, I'm an artist. I can put some art on the backside here. So we decide to actually put some art on it. So then we just make every layer invisible except for the green layer, which is the silk screen on the backside. And then we take an image. We could ask Bing for an image, because Bing is a very nice provider of sort of free images. And we can write something like a robot singing in space, because yeah, that's what robots do. They sing in space, at least in my world. And while we're at it, we start Photoshop, just because we must make the file very simple. So we just hope that we will get some image from this. Oh, that looks really bad. All right, so it's really bad, really bad. All right, so maybe make it 1960s robot. Yeah. Yeah. You can also ask it if you want. You know, you can get this kind of image as well if you like this kind of Nintendo art. So that's a little better. Still looks like shit, but you know, we have to go with it. Well, let's see which one looks least bad. Well, you know, I'm biased because I'm an artist, so I have such a large. I mean, maybe you think it looks good, and that's absolutely fine for you to do that. I have nothing against that. So remember now that the image will be printed with white on green background. Possibly you could print it on other colors as well, but so we just remember to do this. We desaturate the image because we only need two colors here, so we need black and white. So it's very simple. And this is, yeah, maybe this looks kind of okay. I'm not certainly sure. There's a couple of things we could do. We could pixelate it, and how do we do that? I forgot, but yes, we do like this. We take the mode, change it first to grayscale, we flatten the image, and then we make it into a bitmap, and we type 300 inch here, and then we take halftone screen. Wait a minute, yes, halftone screen, and we select the ratio of the screen we want, and I don't exactly remember. This is way too large. We have to undo that and redo it with a much larger screen. So the frequency will be maybe like this. So you see, now we're getting somewhere, but now we are at, we need to go down maybe just a little bit. So go back, go back, go back, go back. Yes. Yeah, what we need to do is first maybe change the levels to sort of something like this, where we are having a very, very little contrast. And then again, we do it to bitmap. Yes, and we have somewhere in between where we were before. So that looks even more like shit. So, you know, it's like really impossible to see what it is. So we just go back again and we, yes. Oh my God. All right. Sorry. So, you know, you can always skip watching this video if you think it's just too bad, you know. That's totally fine. All right. So we have something here that looks like something. At least it's not totally, absolutely the worst thing we've ever seen, but close to it. Anyway, so just sort of maybe make some, yeah, make something like, let's see, we will take this and just sort of cut out a little bit like here, a little bit like so. So I'm just gonna remove some of the background because it looks like shite to me. I mean, how many planets does Bing think there are in space, you know? So we could save one planet here. That could be beautiful, and yeah, sort of like this. You know, it is quick and dirty, but you know, you still have to make it beautiful. Am I right, people? Am I right? Yes, you're so right. And then we just delete that. And then we, of course, we have to, excuse me. Okay, just undo that again, and then change that, and then delete, yes. So then we remake it into a grayscale, and then we make it into a RGB, and then we make it into image size. We have to change the image size. So we maybe want 500 by 500 pixels for this. And then let's see what we did. Oh no, we fucked it up again. So just go back, and we have to, yes, maybe we just go with, let's see here. Yeah, let's go with just maybe this part here. And then we make this into 500. But first we could change the what's it called? Yes, we do a filter and we add some blur on this like that. And then we take levels again. All right, so we have something, and then we take this and we select and we invert it like that, and then we save this as, I don't remember what kind of file we need that we can test to save it as. First this, and then save as, yeah. Let's just take a couple of formats so we're sure that it's going to work. You can say that this EasyEDA, it has the ability for us to import an image here, but it is definitely not created to handle images. So let's just say that that's the way it goes. So it's sort of very hard to get it to work. Yeah, let's see here. No, this is correct, but we need to make it a little bit more like that, yes. And then we take the size here of the board, so it will fill out the entire board. Or maybe that's okay. We do it like that. Insert image to PCB. And now the program might get hung up on an infinity loop. But we had quite a small image, so hopefully not too problematic. Anyway, it seems to have gotten stuck here, so just as I imagined. All right. Yeah. Should have reminded you that we need to press save before we do this because, yeah, even now we lose everything we haven't saved when the program gets stuck. So we have to close it down and start it again. So where are you? Where are you, my little hobbit? It's not a hobbit, it's a program. EasyEDA. It's the easiest EDA in the world. No, I did not want to download the latest version. Did I click I wanted that? Well, let's just say that I did not want to do that. All right, so we have to go back and hopefully we didn't unsave too much. No. So the only thing we have to do is like this, and yeah, maybe we need to make the image even smaller. So let's try to change the image size. Oh, I forgot to change the image size, so that was why it got stuck. So this is good enough, and we file save as. So this is 500 by 500 pixels. And I call it small now, so we remember it's small. And we have a BPM, bit file map, whatever, because it's not supposed to be a very large file. And let's try to use that, and yes, and let's take the color up to a grade up there. And then we could, let's check what that do. Well, it doesn't do very much. So let's just go with this, import to PCB. Oh, it's got hung up again. Would you believe that? Of course you would believe that. No. Oh, fuck you, shitty program. All right. Anyway, it doesn't seem to want to work. Maybe it's because the computer is not liking when I also do screen catching at the same time. So thank you and see you later. Nerding and hoarding. Quick and dirty DIY electronics.